In this video, I want to do some of the homework problems from page 163 just to kind of help you out and make sure you're able to figure out what's going on. So on that page, we're looking at problems 123 through 130. So I'm just going to do some selected problems. So I'll start with number 123. Actually, let's jump to 125. 123 is pretty basic. In problem number 125, the problem that we have is y is equal to 5 to the x, I believe that says minus 2. So y equal 5 raised to the x minus 2. Now remember the derivative of a to the u, and this is an exponential function, is a to the u du times the ln of the base. So the derivative of this one would be a to the u, so keep the function, times the derivative of the power, and in this case the derivative is 1, times the ln of the base, which is 5, so we get y prime is equal to, and the order that you write this in doesn't really matter because it's multiplication, times the ln of 5. Alright, let's take a look at let's take a look at 129. In number 129, we have a product, and we have h of theta equal to 2 to the negative theta times the cosine of pi theta. Remember, we keep talking about the right tool for the right job. So this problem requires the product rule. So I'm going to take the derivative. The first is 2 to the negative theta times the derivative of the second. The derivative of cosine is negative sine of the angle times the derivative of the angle. The derivative of pi theta is pi, plus the second, which is cosine pi theta, times the derivative of the first. So I'm going to have a to the u, so I keep the function itself. The derivative of the power is negative 1 times the ln of the base. Could we factor out? Well, yeah, we could. We could factor out a negative 2 to the theta. We could factor out a negative, or I don't know that in this case it's going to help us that much to factor it out, so I might just write it as, I'd go ahead and pull the negative out. And again, pull the negative out. The order that you write this, because multiplication is commutative, doesn't really matter. Whoops, now that's positive 2 to the negative theta ln of 2. Alright, so that's number 129. Let's take a look at take a look at 128. I think we did 129 through 130. So if we look at number 128, I'm just kind of picking some random problems that will hopefully help you out here. So number 128 initially is f of t equal to 3 to the 2t over t. F of t is equal to 3 to the 2t over t. Now in this case, it's your choice as to whether you want to make it into the product rule. You could make it 3 to the 2t multiplied by t to the negative 1, or you can use the quotient rule. And this time I think I'm going to use the quotient rule. So I'll have down, d up, and here comes my exponential function, so I keep the function. The derivative of the power times the ln of the base. So that's down d up minus up d down over down down. And so, is there really anything I can do here to clean up? Nope, can't really divide anything, can't multiply anything. Could factor out a 3 to the 2t in the numerator. This 1 would be gone. So really not a whole lot of cleaning to do there. Let's see if there's any more in there. So we go through 130, maybe 130. Let's take a look at that one. Number 130 is t to the, no, I'm looking at the wrong one, 5 to the negative alpha over 2. So y is equal to 5 to the negative alpha over 2 multiplied by sine of 2 alpha. Sine of 2 alpha. So again, we have the product rule. We have the first function, 5 to the negative alpha over 2 times the derivative, first times the derivative of the second. The derivative of sine is cosine of the angle times the derivative of the angle. Let's clean that up a little bit, make it more clear for you. I'll do that again. So I had the first times the derivative of the second. The derivative of sine is cosine. Man, I'm having problems here. So cosine of the angle times the derivative of the angle plus the second, sine of 2 alpha, times the derivative of the first. Keep the function. Again, it's an exponential function. Multiply by the derivative of the power. Now remember, the power is 1 or negative 1/2 times alpha. So the derivative here is negative 1/2 multiplied by the ln of the base. Cleaning. I could make it, there's not much. I could put the, I could take the negative 1/2 over here and just make it, nope. I could stick it in front or whatever, but that's about as clean as I'm going to get it for right now. All right, let's see if there's anything else that I think might be challenging for you. Now, I know the graphs in 139 through 142 you might have some questions on. I don't have those on the board, so I can do that in class with you. Number 103 looks okay. 145 are the symbolic derivatives, so if you have any trouble there. I will go ahead and do 103, and that's kind of how I'll close out this homework video. In number 103, they're asking you to find the second derivative of sine of x squared. Second derivative of sine of x squared. So y equals sine of x squared. First derivative, the derivative of sine is cosine of the angle multiplied by the derivative of the angle. So that's first derivative. Second derivative is going to require the product rule because now I have a product of 2x multiplied by cosine x squared. So I'll have the first times the derivative of the second. The derivative of cosine is negative sine of the angle multiplied by the derivative of the angle. And the derivative of x squared is 2x plus the second, which is cosine of x squared, times the derivative of the first, and the derivative of 2x is just 2. Cleaning up a little bit, I could factor out 2's or whatever, or I can just multiply it together and make it negative 4x sine, that would be negative 4x squared, sine x squared, plus 2 cosine of x squared, and the only thing that we could factor out is a 2, and so that's how you find the second derivative. Hope this helps you.